Hi, I'm Kian and I'm back with another video, and today I want to show you how to solve this physics word problem. So we have this question. The question says that a monkey leans over the edge of a cliff and throws a banana straight upward with speed of 20 meters per second. The banana lands on the ground 60 meters below its starting position. So for this question, we want to find for how much time is a banana in the air, or find the time. So first, you want to label things. When I said with an upward speed of 20 miles per second, I meant that in this case, or you can write it 20 miles per second, 20 mile per second is our initial velocity. Which our initial velocity also can be written as v sub y0. v sub y0. And now, where I said 60 meters below its starting position, 60 meters below its starting position means negative 60 meters, which in this case, negative 60 meters is the net displacement. Negative 60 meters is the net displacement, which is shown also as delta x. So for our next set, we want to find the value of t. So we want to find what is t. So we can use a very famous physics equation, and you should remember, usually if you're taking AP Physics. So the equation states that delta y, which in this case is the, and I should here wrote delta y instead of the delta x. This is a better choice. Delta y. This is delta y. And now we can use a famous physics equation that all physics students know. And we use that equation, which states that delta y, which is the net displacement, delta y is equal to the initial velocity, which is v sub y0, times t, times time, which we want to solve it for time, plus 1/2 multiplied by the acceleration, which is in this case, we call it a sub y, multiplied by t squared. Now, we should just plug in. But I should mention that for acceleration, because we're talking about surface on Earth, we should use the acceleration as negative 9.8. As in the acceleration. And in this case, because we said that the monkey throws the banana straight upward with a speed of 30 meters per second, we say that the acceleration is actually negative 9.8. But because we want to have a better approximation, in this case, we use negative 10 as the acceleration. So we should just plug in. So when we plug in, we have delta x to be equal to a negative 60 meters. So we say that negative 60 is equal to the initial velocity, which is this case is 20 times t, 20 times t, and then plus 1/2 times the acceleration times t squared. So let me mention here, let me write a note, that in this question always is approximately negative 9.8, but we use it as negative 10 for a better approximation. Ay is equal to negative 10. So when we use it at negative 10, what we get for our value is that 1/2 times negative 10 is just negative 5, so plus -5, and then times t squared. So we can see that we have a quadratic equation. And now for a quadratic equation, first of all, we can factor out -5 in the right-hand side. So if I do that, let me write it with this color. So I get -60. If I factor out -5, 20t divided by -5, so let me take out -5. So I get -5 multiplied by -40, -40, and then plus t squared. And if we use our distributive property, we get the same expression as the right-hand side. And now we divide both sides of the equation by -5, so we can have a more simpler and easier equation. So here we get our new equation, which is 12, because -60 divided by -5 is 12. 12 is equal to -5 and -5 cancels. We get t squared minus 40. T squared minus 40. And now we can subtract both sides by 12. So we get t squared minus 40, and then minus 12 is equal to 0. And now we can solve this equation very easily because we can factor this equation out. So rewrite here x, and close the parentheses, x, close the parentheses, equal to 0. Now, we say that, so what two numbers multiply to be -12 and add to be -4? And that two numbers are -6 and 2. So for the first part, I write -6 and +2. And now we should set each equation equal to 0, and our solution, I write it right here. We get x is equal to 6, where x is the same as t. I changed the variable because we can notice it a little better. And also x equal to -2. But because the banana has gone straight upward, we're solving only for positive values. So for our final answer, t is equal to just 6 seconds. Thanks for watching. Please subscribe to my channel and watch previous videos.